Well, thank you so much. Congratulations, firstly, you guys have reached the last session of the first day. So you guys are still alive. Good to see that.
Yeah.
And I hope we will keep you excited for the last 45 minutes before we let you guys go home. And I'm guessing as engineers, you don't get the chance to go home at this time of the day. So we will try to end early. So my name is Chinab, and this is my awesome colleague Fahmi. Together we come from Jublia, the sponsors of this event. The PyCon app, which you guys have on your phones. If you don't, I do urge you guys to download it. It was proudly built by us. And we love Python. We are a 100% Python-driven company. We love how beautiful the syntax is and all the community, and that's why we come back year on year to sponsor the PyCon events around the region. I promised to Fahmi that I won't be talking much about Jublia because that's not what you guys are here for, but to set the context right, I just have to explain a bit about what we do. So at Jublia, we make attending conferences and B2B exhibitions worth your time by intelligently matching people and content at events. So our core system is a one-to-one meeting system, which is personalized to your usage, and it would send you recommendations based on how you've been using it. So imagine from the time you register till after the event, everything is catered for by Jublia. That's where we stand. So we have realized people attend events for two different reasons, and they are for generating contacts, and second is to listen and contribute to the content at an event. At Jublia, we put the two together using our product smartly, and the two products are Match 360, which is our one-to-one meeting system, and the fully branded app, which is what you guys will be using for PyCon. So having worked with over 2,000 events, we have realized that every event is so dynamic. There's so much happening at any point in time. There are sessions happening, there is exhibitors outside who are doing product showcases, and then there's networking sessions going on. So there's so much to do and so much to be at any point in time. But one problem we see is how to find your way around these events. And as the venue grows bigger, the problem intensifies. So you would be thinking the obvious solution is doing a floor plan, a traditional floor plan, which would be maybe a PDF document on the website, or while registering on site, they could hand a pamphlet which has a guide of where the sessions and everything is happening. But what's the problem with these traditional floor plans? The first, it's difficult to find points of interest, so you cannot search. If you have 1,000 exhibitor event, which is over SingX, which is 10 halls, you can't use a pamphlet to find what you're looking for. It's not portable. You're looking at a huge paper in front of you, or a PDF which you keep on scrolling to find what you're looking at. It doesn't cater very well to multiple hall venues. For PyCon, it makes sense, but as the event grows bigger, it doesn't. Like some of the bigger events we have done is 70,000 people and a huge number of conference sessions going on, like 15 conference sessions going on at the same time. So it's hard to capture that in any or a traditional floor plan. And lastly, it's static, and of course it's dull because it's just a piece of paper. Static because you cannot update that in real time. So today's talk will focus on converting a static image to an interactive floor plan. We'll be going from a JPEG or a PNG all the way to something which is interactive, and of course everything in Python. When I say interactive floor plan, the first thing which comes to your mind are apps like these, which you would be probably using even to come to the venue today. So these are very commonplace apps, and they have few types within them, like there is terrain apps, there's road maps, and so on. But indoor floor plans are traditionally more different than this, but the concept is the same. Have you ever thought of what happens behind the technology of Google Maps or Apple Maps? So we were thinking about that when we were creating this product of ours, and we took a look at some examples. And today I'll be sharing one with you, which is the traditional approach of generating something like Google Maps. I'll be using the example of a mapping technology called Mapwise. So in Mapwise, this is what happens. First, you start off with a custom file format. Generally, it's something like CAD or something in MATLAB, and you map your point of interest. Like this is maybe a conference hall, and you can drag it and mark this. So in this case, we call this a polygon. And once you have done so, you can label your polygon. So you can write a name, you can put a tag around it, and you can do this for all your points of interest. And after you do that, you can set up routing from point A to point B. So this is also done manually here, but of course, I don't imagine something like Google Maps doing it manually, but there are some companies who still do it manually. If you have 10 points of interest, you're doing 10 factorial over there, so that's totally ridiculous. But in the end, you get a good-looking application, which has been created after several hours or even several days of hard work. We want to challenge this because it's too repetitive, and it uses only selected file formats, like I mentioned, to be able to achieve this. Generally, file formats which have a layer where you can interpret your top layer, which is the SVG layer. But within the events industry, people don't have these complex file formats. We're talking about event organizers who are just used to images or who are just used to PDFs. They want to make that interactive. They cannot give me a CAD file. So that's something which we will be talking about how we solved. So going from simple file format all the way to interactive using one click through our floor plan engine. And what does our floor plan engine constitute of? The first is the user would upload the image. Now, of course, like I mentioned, it's no special image format over here, but the image quality is still very important because we understand the different characteristics of the image based on the quality. After that, we have an auto scan function which does three things. The first thing is it automatically scans the booths. So the booths could refer to the exhibitor booths. It could refer to the conference halls and other points of interest like the toilet area or the canteen area, which has been labeled inside there. Second is it links it to the event database. So as a company, we work together with event organizers so to give us the database of exhibitors, and we can link this to the database automatically. And lastly, we find the best path of routing automatically. And this engine works for majority of the cases, which we will of course be discussing what are the cases which are left out. So if there's any unprocessed point of interest, the user can go and manually correct that. These are some of the technologies which we use to make our product happen. Now, I will be sharing them so that everyone is on the same page as me over here. The first one is, of course, Google Maps Platform. Google Maps Platform provides us the front end for us to render the floor plan image, as well as it provides us a coordinate layer. That's where the SVG comes in for us to put polygons to represent the different points of interest. Now, something interesting is that Google Maps uses image slicing. So depending on your zoom level and location, it will identify where you are, and it will give you the right resolution of the image. So that when you're inside that image and you're scrolling around or zooming in, it doesn't take too much time to refresh. We use OpenCV. I hope a number of you guys have used OpenCV. So we use that for a few things like binarization. Binarization is for converting an image to a black and white format. And we also use it for identifying contours. So in the image you see up there, anything which is the green line is the shapes which we call as contours or polygons. We will also be briefly sharing about our usage of TensorFlow. So we are using a convolutional neural network on TensorFlow for identifying an image and classifying what is a point of interest and what is not. We make use of Google Vision API. So Google Vision API is used for image detection, where we could read what is the text within the polygon and identify that and use that for tagging. This is something to show triangulation. So we're making use of triangulation. There is a pip library for that called Triangle, and we make use of that for identifying a location based on other given locations to us. And we make use of the A-star algorithm for achieving routing from A to B. Now, A-star is similar to Dijkstra, but of course different, whereas Dijkstra is more of, there are several paths, whereas A-star is, it prioritizes some nodes over the others, but it still finds you the shortest distance between two different paths. And lastly, we make use of Python, of course, to gel everything together. Now, this is how a floor plan traditionally looks like. I hope you guys have used the PyCon app. We have done the floor plan, the interactive floor plan for them, but the floor plan given to us by the organizers was a bit too simple, where we were only given two large areas, W2 and W4. But generally, this is how a floor plan looks like. So this is SIGGRAPH Asia Tokyo, which is one of our clients. Now, you can notice over here what is happening is there is normal rectangular booths, there could be square-shaped booths, but the complexity comes in because there is tilted booths, there is different colors, and there is irregular shaped polygons as well. So our engine should be covering not only the simple cases, but should be able to identify all of these. So with this in mind, I'm going to leave you guys to Fami, who will be sharing how the floor plan engine was built. Basically the cool stuff.
Okay, hello everybody. So I'm very happy finally I can share this to you guys in Singapore here. So I'm from Indonesia and I work as a software engineer in Jublia, and I'm part of the project lead for this feature. So I'm going to share you a bit about more deeper about the technology behind this. So this part will be divided into three parts, which is the first one is the booth detection, and second is the OCR and linkage, and last one is the routing. Okay, so let's start from the part one. So this is the flow that we use for detecting the booth. First, of course, you need the image to be processed. The image can be like JPEG or PNG, and then we do the binarization for the image. It's actually like converting the image into like binary, which is 0 and 1, and if it's applied to the image, it will be like black and white. So we have two methods for that, which is the symbol threshold and the adaptive threshold. And from that, we can capture a square with our trend. We can detect the counter from that binarized image. So the counters are actually a shape detected from the binarized image. So I will show you later about how it looks when the image is binarized. And after we find the counter there, we can compare the detected square, the counter to the loaded pre-trained models that we have. So yeah, and then if it's detected as a booth, we will store the coordinate of the detected booth to our database. So the coordinate is the one that we, the front end use for generating the polygon. So it will be created a SVG layer over the Google Maps. Okay, so this is the example of the binarized image thing. I have one sample. This is the original image. So we got three booths. The first one is the colored booth with the block color. So it's blue, and second is with the blue line outline, and last one is the gray one. So it's maybe a bit unclear on this projector, but it's really a gray. Okay, so what we do first is the adaptive threshold. So This is the good thing for using OpenCV. They already gave some bunch of function of processing image. The adaptive threshold will automatically find the best threshold for you to like separating the color into black and white. So, but it's not so good on the color. And you see that on this one, we got a bit broken text, so it will broke our data when we pass it to the model. And to avoid that, we do the correction using the second method, which is the simple threshold. And it will detect the line better, like for this one. But it won't work well for the gray one. So it don't detect it on this simple threshold. Okay, so once we got the binarized image, we can do the fine counter. Again, this also already built-in function from OpenCV. So what it does is, it will detect a white shape over the black area, and it will create a line over the area and add the points like this. So if you ever do editing image like on vector using Corel or GIMP or something, then you will often see something like this. But we don't need that much curve on this one. So we do the simplification. And the final one will be look like this, which is square. Okay, so this is the result from the counter detected that already simplified into 4 points. So we can assume that both is box or square. And based on this one, because we store the coordinate for the path and the location, so we can compare to the original image, and we can use that counter to crop this image. So we call this as a region of interest. So we will use that result to pass into our preloaded, pre-trained model. And yeah, of course, we need to resize it to fit the models. Okay, so next thing is we will try to detect like, is it a booth or not? So I have some example on this. So this to make it simple, I just create this one as a booth, which is square with this B36. This is we call as either identifier or booth number. And this one is actually a square with cross one. Usually, organizer use this kind of symbol to identify that there is no booth there or no one using that booth. Okay, so once we got this crop image, we can put that on the trained model. So CV got that can support model from TensorFlow, so we can just load it and we can pass the image into the model. And if we pass like this image, so let's say we already cropped this 1, 2, 3, 4 booth, it will got a result like this. So this 3 square is detected as booth, but the last one is no, of course, it's cross. So yeah, no booth. Okay, and then once it's detected as boot, we store the counter like I said. We have some particular format for storing this counter into our database. So we store like the X, Y thing, and what's the identifier, what's the type of booth, because there's a lot of type actually. We have the general booth like toilet, cafeteria, and we have the meeting booth. And this one is like exhibitor booth. Actually, we have a data that our exhibitor have this identifier. So usually if you attend an event, you see that from their floor plan, exhibitor A is on B36. And then you will open the floor plan and see, oh, where is it? And you're going to the left and to right. Okay, then you get lost again. But if we can detect this text automatically, we can link to the exhibitor data automatically from our database. Okay, so this is the demo part. It will be more clear about the binarization thing and the conversion. Yeah, so if you still remember this image, this is actually already showed on the slide that Chinap said this is the example of most floor plan case for each event. And we'll try to do the conversion. Yeah, this is the first method that we use for binarization. This is the adaptive threshold. And you see that on the color one, it successfully detects the contour. So the the green line is the detected contour. So yeah, you can see still a lot of detected also other than this box. So that's why we need another method to correct this. Then, okay, we can go next. And this is the simple threshold that I said we need another method to correct that one. And you can see the simple threshold will fail to detect with colored booths, and it can just detect the booth with the very clear line. Okay. Yep, then we go into another threshold. So basically we have a range of threshold. We start from 50 to 20 to 100, and the value may be vary for many cases, and this is the best value for our cases. So we use this one. Okay. Yep, and actually before we do the conversion of the threshold, it is split into each channel. So usually image have 3 channels: green, blue, and red. So it will be going into 3 iteration, and then each channel it can be iterate also from each threshold. Okay, I think it wait a bit. Okay, so I think I got a bit lag on this processing. So, yep, I think this because the connection. Yep, let me rerun again. Yeah, this is because we run the OCR using the Google Vision, so we need to connect to the internet. Yep. Let's just go through the. Yeah, I wrongly clicked the button. Okay. Okay, I hope the connection is still good. Yeah. That's right. Yes, waiting the connection. What?
It's connected?
Yeah, actually connected, but no connection. Okay, sorry for the inconvenience, guy. Okay, I think we can. Yeah. Okay, I will run this after I explain also for the OCR part, and I will just reconnect this one first. Oop. Nope. Okay, so I think we can go to the parts 2 first, which is the OCR and linkage. Yeah, so if you still remember that we have the crop image that we pass to the models, yeah, we also pass that into OCR engine. And then, okay, then if it's detected the identifier, and it will go through the database and check which location have the relation of that identifier, and then it will be linked also to the exhibitor or agenda session. So if there is a session or conference, you can see that list of session like what we did on the PyCon Singapore app. So you can check the session list from the floor plan. Okay, so when we do the OCR thing, we have like a bit dilemma between these two engines. So actually, the two of this engine come from Google. Yeah, but let me show you a comparison between these two engines based on our testing. So, okay, you see that this is like a typewriting font, and Tesseract result is like this. So like this, is it clear? Yeah, it's like almost fail on the like some of the sentence, but Google Vision is like, oh, so clear, but still fail on the emoji because emoji is in text, right? Based on that, we think that Google Vision is more accurate, work on the color image, because Tesseract you need to make it binarized first to make it detectable of the text, but Google Vision is you need to have in the Google Cloud Platform, and maybe you need to pay. But the good thing for Tesseract is it's free. So yeah, if you can afford this one, you can choose this one, but yeah, you got this result. Okay, then based on that one, because we don't want to like correction a lot of booths, then we choose this one because it will make our work easier for linking between the booth into the exhibitor data. Okay, I hope this one is work. Let's rerun again. Mm-mm. $200. Yep. Okay. Yep.
Do you want to try my internet once?
Okay.
Let's try reconnect.
What's yours? I think I need to stop it first. Yeah, see, the error is the Google.api. No? Oh yeah, it's connected. Let's see.
Fingers crossed, guys.
Yeah.
Let's talk.
So imagine you are releasing a product in the production and it going.
Well, hopefully you're not connected via like mobile data.
Yeah.
Connected to proper Wi-Fi.
Okay, let's rerun again. Okay, it's processing. I hope it works because I can control the connection. Thing doesn't work, you know. This is your phone, right? Yeah. Okay. Yep. Think Google Vision doesn't want to show you the abilities. So okay, then I think we can go to the last part, which is part 3, and that one is actually the most interesting part, the routing. Once we got the contour from the part 2 and part 1, so we will draw that contour into a black and white image. So we create a black and white image, and then we draw the contour into outside that booth, and we create a triangulation between the contour that created outside the booth, and we will set that as a walkable path, and then we will choose a 2 point A to B, and the engine will find the nearest path using A-star algorithm, and of course we then simplify the path by reducing the point. I will show you this on the next slide. And okay, so this is the black one is the contour that we already detected from the process 2 and 1, and the white area is the walkable path. So, and this is how it looks once we draw the contour on the black and white, and we also apply the base image. So you can see that there is a booth, and this is the walkable area, and the booth is not drawn by this line. So your route will be not like going over the booth, so you don't have to like, okay, this booth is not this is not a pathway. So yeah, and then we do the triangulation between this contour, and then we generate this line as a walkable path. And yeah, you can see that there is like a road, but actually this is not a nice road because, you know, like not so straight. Then you can choose from point A to B. Let's say you want to go from this booth into this booth. So which way to go better? You can go that one or this one, but the algorithm choose you to pass this way. But you see that there is not a straight way. So I don't know who will follow this way. And then we will simplify that for you. So we make it easier for you, just going straight, going right, and going left, going right again, and you got your destination. Okay, so this demo actually not using internet, so I hope this will work well. So this is the interesting part. So if you guys already going to our booth Jublia, you can take the maze one I think Chinap, you can help me to share the maze.
So for the people who don't have this, I can give you guys a copy.
Okay, so is everyone got their card? So you can see that maze is actually the same as this one, but with a big Jublia logo. So you can try to solve that if to create a path between this point to this point or this point to this point, whichever you want. And then I will show you how it's done using this routing algorithm. So, okay. Let's do the demo. Yep, so like I said, we wrote first the contour on the walkable area, which is this the white area, and the blue color line is wait. It got zoom. So after the blue area, we will draw the walkable the route. This is for the green. Is it green? Yeah. Okay. Assume it's green. Yeah. With the dot is the walkable area. Then we go next, and yep. Okay. So we finally got this image. So I see this a bit not so clear. I will zoom a bit. Okay, so let's say I want to go from this path into this path. Then we can just click the start point. Oh, yeah, this one to this one. And yeah, it's just done. And then I will try from this. Is it possible to go in there? Because I don't know. Oh, yes, you can. Nice. But yeah, because it's a maze, then the walk is not so straight. Yeah. Okay, so I will pause a bit so you can follow this path for drawing the maze. Okay, so I think that's for the routing demonstration. Then I will passing time to Chinap to recap some of this presentation. So over to you, Chinap.
Okay, how unfortunate that one of our very exciting demos didn't work, but I hope you guys still got an idea of how the full system works. And the last one was quite exciting for us to do. So whatever you saw in routing is actually being used in a number of exhibitions out there, and it helps you route through different mazes and different ways of getting around from one place to another, the same way how this maze was built. So now I'm going to just summarize. This is the last part of our talk. So a quick summary of what we have spoken about and a conclusion. You guys probably should take away that events in general are so dynamic and there's so much happening at any point in time that there is a need for events, be it small or large, to have an interactive floor plan. And that's where this technology really comes in. And we showed you how to go from a static map all the way to an interactive floor plan in 3 different parts, which was the boot detection, OCR and linkage, and the routing. And of course, in our engine, we combine it together, and the user doesn't know that there are 3 parts. It's just one click. It takes about 2 minutes to 5 minutes, and you get an interactive floor plan after that. And lastly, what's the future steps for Jublia? So we are going to go into multi-hall routing, where we can identify the exit and entrance point between different halls. Second is to cater for non-polygon shaped booths. So right now we only consider 90-degree polygons. So it could be 7-sided polygon, but it has to be a 90-degree. But we are hoping to consider even like oval-shaped booths or different kind of shapes. And lastly is something which I am super excited about is recommendation trails. So when you go for these large B2B exhibitions, there are so many exhibitors out there, you don't know which ones you want to go for, and you probably have a time of 3 hours. So we want to put together our recommendation engine, which is something Jublia has been working on for past 2 or 3 years, together with the floor plan. So when you walk in, you tell what your interest is, and it will draw the route through the recommended booths and the conference sessions. So that is something which we're planning to roll out in the next version. This is a list of references. So for anyone who's interested in this project, these are some of the algorithms and some of the data sets which we have been using. So feel free to take a picture, or we'll be sharing the slides later. Okay, and that brings us to the end of the presentation. Thank you, everyone.
Thank you. Do you guys have any questions? We have some time left for the questions.
So you use OpenCV to detect the contours, but is that also used to vectorize the image? Or is the contour the vector that you then use?
Yeah, so from the detected contour, we set the coordinate from that contour to the database. So we get the result as like x, y coordinate. And then we use that coordinate to draw the polygon using Google Maps API on the SVG.
The contour gives you the corners, you connect it, and then
Yeah.
you create a polygon.
Yeah, and Google Maps already cater for that, so it makes our works more easier for now. And yeah, actually that. And actually the result is, the simple version of this result is on the Python Singapore application. You can check on the floor plan, and the polygon red one is the one is the generated from this engine. Actually, yeah, it's only 2. Okay, well, thank you.
Another question. Yeah, so this pipeline is quite like long, right? So was there any particular stage inside the pipeline that you found particularly difficult to implement? Like what was the hardest stage in that pipeline that you felt from an engineering standpoint to develop?
Okay, so speaking of, we are doing the boost detection. There are so many layout of floor plan we facing. So there's like actually the data and the quality of image. So sometimes our organizer is like, okay, we only have this image, it's like maybe only 500 by 500 pixel, and imagine that being converted using this engine, so it will be like very pixelated, then there's no boot detected. And yeah, but that is the scope that we cannot do that. But for detecting the boot, we can add more models, add more sample for the training, so we can get the result better after this. Yeah. Also, the multi-hole routing is also a bit challenging for us because we can find the path, but we don't know because it is actually combined more than one image, and we need to set the connecting point between 2 images before we can do route between 2 images. So yeah.
Thank you, Julia, for this amazing idea, and it helps the organization work easier, I think.
Yeah.
But actually, is it possible to do the same approach to multi-level building? I mean, if the event is located in while building this multi-floor.
Yeah. So we are we are really thinking about that when developing this, and usually each event can send us more than one image. Okay, let's say floor 1, floor 2, and floor 3, and we can just convert that into using this engine, and yeah, it can be automatically linked to the exhibitor data based on the location. So let's say the floor one is have the ID like 2A1, and then the second one is 3A1. Then we can just link it. Yeah, and that also what we call as a hall routing. Like the multi-hall is actually can be also sometimes multi-floor or one floor but multiple hall. Yeah, it's a similar case for that.
Yep, so just to add on to that, actually what Fahmi said in the end is exactly the same as multi-hall routing. From one image to the other image, we need to know the entrance and the exit point. That's for multi-halls. The same for multi-floor routing. We need to know the part where you go up and the part where you come down. So the escalator needs to be marked, and you can mark those using another polygon, which is what we call in our system a point polygon. Whatever we showed you today was more of an area polygon. A point polygon will just store the coordinates of a single dot, and that would be your exit and entry point to that image itself.
Can you also find the shortest path between multiple destinations?
Yes, so that is exactly what I mean by the part about recommendation trails. So as a company, we focus on people-to-people and content-to-people recommendations, and this floor plan thing is pretty new to us. So we want to route you through different polygons within a floor plan or multiple floor plans based on your recommendations. So say, for example, there's 100 booths out there, and your interest is in AI. We will route you through only the AI booths, depending on how much time you have at the event. So it'll select the 5 best booths in your walking path and then send you out as well. So that is the next step which we are working on.
I have questions. How do you start getting all these floor plans to start this project? Do you like Google images and like how do you get like, cause for the map, the roads, it's understandable you have Google Map, you have Open Maps out there, but in terms of building floor plans, how do you start like getting all those data?
So since we've been working with so many different events out there, they always give us a static image, which is used for our business matching system, where people can use that to scroll left and right on the image to find where the meeting will take place or where the exhibitor booth is. So we have a database of images, but while working on this project, we had to score the whole internet to find other events out there, those mega size events, to find their floor plans and use that in our training data set.
Okay, that's really cool. Because I thought about like how you get started with the training, because you do need a little bit
Yeah.
of cycle.
The object matches an alphabet, how do you guys differentiate that? Say a polygon like a T-shaped building or T-shaped room is matching with an alphabet, because like it was saying the SIGGRAPH Asia, right? So T was there, H was there. So how do you guys differentiate whether it is an actual room or like whether it is an actual character in the floor plan?
Okay, so there's several cases which I think Fahmi can share more about. So there's several conditions which we use, like rule-based, and the second is through our TensorFlow model, which is trained to ignore some of the booths or which should not be classified. So it's a multi-pronged strategy, and I think Fahmi can share more about those rules which we have, like the size and stuff.
Oh yeah. So
Sorry, can you switch on the Wi-Fi? It's causing a buzz. It's static.
I
Is the
don't.
Wi-Fi still on? Can you hear the static?
No.
Yes. I can ask the people.
Yeah, it's gone off. You just need to off.
take my phone.
Maybe your phone.
Yeah, so before we pass the image into the models, we do some comparison between data. So first, we can compare the size, like the booth, with the total image size. Is it make sense if the booth is very big? Think no, right? Then we can ditch that before we put that into the models. And also we look at inside the booth. Is it have the tags that have the pattern for the booth number, or a value of the identifier. So if it's like just like the cross square block, so that one doesn't have tags or anything. So we don't say that as boost, something like that. And when it passed that, they also still need to check by the TensorFlow model. And yeah, I think that's it.
Yes?
So, my question is actually more like, so, what do you expect that like, who will be your end user? Is like to promote to individual people or to collaborate with other like event holders to maybe collaborate with them and maybe you can get a simple input data?
Okay, so we are a B2B2C company. That means our clients are event organizers. We get the registration data, the exhibitor data, the floor plan from them. And we launch this service of the floor plan, the event app, our business matching system to the event attendees. This could be the delegates, the sponsors, the exhibitors. So we get all the interactive floor plan data from the event organizer. Yeah. Okay, I guess that's all. I just want to credit my team for making this happen because it's not just the two of us. So thank you guys, Yuhang and Roy as well, for all the hard work we put into this.